Let's start the solutions. In the first A part, we have to expand a simple binomial with a square outside. That means we have to square it. So we can use the identity A minus B square, which is A square plus B square minus 2AB. So in this case, A is 1 and B is 1 over 2x, not minus. Minus is in the identity itself. So first A square, which will be 1 square, plus B square, which will be 1 over 2x square, minus 2 times AB. Okay, this 2 and this 2 get cancelled, so we'll be left with 1 plus 1 over 4x square minus 1 over x. Done. B part, it says find the first 4 terms of expansion of this particular binomial. But since it is power 6, it will be needing the binomial expansion formula. Here in square we didn't need it, but here it is needed. We could have applied it here in the A part, but because we knew this identity, it was easier to do this way. So to expand these first 4 terms in ascending powers of x, that means first we should give 2x to the power 0. Ascending, we start from 0 whenever this is ascending powers of x. And let's write everything else. That means 1, which is the other term in the bracket, will get all of 6. And here it will be 6c6 in the starting. Next will be 6c5 and 1 to the power 5, but 2x will increase by 1. Then 6c4, 1 to the power 4 and 2x squared. And lastly 6c3, 1 to the power 3, 2x cubed. We could have written 6c0 also. This particular number must match with either this or this. It does not matter which one you write first. Okay, so because I wanted to match with this 6, that's fine. 6c0 and 6c6 are the same thing, so it won't make any difference. 6c6 will be 1, 1 to the power 6 is also 1, and 2x power 0 is also 1. 6c5 is 6, 1 to the power 5 will be 1, and 2x to the power 1, 2x. 6c4 will be 15, 1 to the power 4 is 1, and 2x square will be 4x square, plus 6c3 will be 20, 1 cube is 1, and 2x cube will be 8x cube. Did you notice that I cubed 2 as well as x because cube is with the whole bracket? And let's write the simplified form of this. 1 times 1 times 1 is 1, plus 6 times 2 will be 12x, 15 times 4 is 60, and then 20 times 8 is 160 x cube. Part C. So hence find the coefficient of x in the expansion of these two. Both have been answered in first 2 parts. That's why they've written word hence. So let's write the expansion of the first one, which will be 1 plus 1 over 4x square minus 1 over x. That's what the expansion of the first one. Second was 1 plus 12x plus 60x square, 160x cube. Now let's focus on the terms that will give us x when we multiply. So 1, what should I multiply this with to get x from the second bracket? 12x is the one. So 1 times 12 will be 12. Let me write x also to make it simpler to understand. Okay, second is this term 1 over 4x square. I need an x cube on top. If something over x square is there and I have an x cube on top, I will get an x. So x cube is this one. So I'll multiply 1 over 4x square with 160x cube, and I will get x. So I'm cancelling this with the 2 of the x's, so I'm left with 160x divided by 4. We can cancel 4 and 160 also. So now we are having 40x, again x, okay? Third term is 1 over x. I need a square to multiply with it so that I get an x again, and this is the one which will give me an x. So minus 1 over x times 60x squared will be x cancelled with one of the x's, so we are left with minus 60 here. So now we will add the like terms because all these three will be like terms and they will give us x. So 12x plus 40 will be 52 and minus 60 x will be minus 8x. So the coefficient of x is minus 8. Alright, next question. Number 2. A curve has an equation y equal to kx squared plus 2x minus k, and a line has this equation. K is a constant. Find the set of values of k for which curve and line do not intersect. So obviously this is a quadratic equation and this is a linear equation. What they mean is that if the curve is going this way, the line is going this way, they are not intersecting at all. So if they were intersecting, suppose they were intersecting like this, the y value of these 2 points would be same. And that's what we will do. We will first equate their y values and then we show that they are not having any solution if we try to solve that equation, that situation. Alright, let's do it. So kx squared plus 2x minus k, this is the y value of the first curve, and it will be equal to the y value of the second curve, which is kx minus 2. And let's merge them now. So kx squared plus 2x minus kx minus k plus 2 equal to 0. This minus 2 became plus 2. This kx became minus kx. And let's make it a quadratic equation now. Kx squared will be the square part, but 2 minus k x will be the x part because 2 and minus k will be in a bracket with x being common in the 2. And minus k plus 2 is the constant part and this is equal to 0. And now we don't want a solution for this. We don't want them to intersect at all. That means b square minus 4ac, which is the discriminant, it should be less than 0, negative. Then only they will not have any solution. And let's do that. This is a for us, this is b, and this is c. And let's substitute them here. 2 minus k is b, so b square minus 4 times ac, a is k, c is minus k plus 2. And this has to be less than 0 so that there are no real solutions. Okay, and now it will become a quadratic inequality by expanding. So let me expand this one by the identity a minus b whole square is a square plus b square minus 2ab. So it will be 2 square plus k square minus 2 times k. Alright, now this one will be minus 4k multiplied by minus k will be positive 4k square. Minus 4k multiplied by 2 will be minus 8k. And less than 0, that's what we want. Okay, so let's simplify this also. So 4 plus k square minus 4k plus 4k square minus 8k less than 0. K square and 4k square becomes 5k square minus 4k minus 8k is minus 12k, and then we are left with the constant part, which is 4 less than 0. And we want to find the inequality. First step towards the route to find the inequality, we must first find the roots, and roots can be found by factoring this particular quadratic expression. I will factor it. You can use a calculator if you are not comfortable factoring. So let me factor, and you can use your calculator to find the solution. I'll find the solutions this way. Okay. By the time I do this, I would like you to subscribe to my channel and motivate me to make more videos like this, so that I make such videos and you and your friends with whom you will share this will get benefited out of this and will have a knowledge that will be forever. So let me complete this. So if it was an equation, the root of this equation would be, this would give me a root k equal to 2 over 5. This would give me a root k equal to 12. But since this is an inequality, we can't say that these are the answers. Never ever say that these are the answers. We should use this method. On a number line, place them. 2 will be here and 2/5 will be lesser than that. So we have three options. Either the answer will be in this range, which is k is less than 2/5, or it is between the two, which is 2/5 less than k less than 2, or third option, it is more than 2, k is greater than 2. These are the three options. And how do we confirm which one is the answer? Let's take a random number less than 2/5. Let me take 0. 0 is less than 2/5, right? So if 0 works, this will be our answer. So let me put it here. So 5 times 0 is 0 minus 2, and 0 minus 2 is also 0 minus 2. This will give me plus 4, right? Plus 4 is not less than 0. That means this is not a solution. Let's take a number between 2/5 and 2. Let's say 1. So if I put 5 times 1 will be 5 minus 2, 1 minus 2. So it will be 3, and this will be minus 1. So answer is minus 3. Yes, it's a negative. It is less than 0. Less than 0 we wanted. So this is the answer. The first answer we have is 2/5 is less than k is less than 2. Let's see if k greater than 2 is also in solution. So let's take a number more than 2. 3 is okay. So 3 times 5 here, 15 minus 2, 3 minus 2. 15 minus 2 is 13. 3 minus 2 is 1. So answer is plus 13. No, this is not an answer. This is the only set of values for k that will not let the two curves and line intersect. Question 3. Solve by factoring the equation this one. So they have already given the hint, factoring. That means we have to factor this out. We have to find the GCF of the first two and the last two, or any other sequence. So let me copy what they have given us. Cos theta tan theta minus 3 cos theta plus 4 tan theta minus 2 equal to 0. Now cos theta is in both of these, so let's take 3 cos theta common. 3 cos theta is the GCF of these two. So we'll be left here with, out of 6, 3 is out, so 2 left. Cos theta is already out, so we're left with just tan theta. Minus, whole of 3 cos theta is out, so we'll be left with only 1. Plus, in these two, only this number 2 is common, so we'll take that as common one, and we'll be left with 2 tan theta minus 1 equal to 0. Now we have two terms. One is this, and 2 tan theta minus 1 is in both. Take that as common now. So what are we left with? 3 cos theta here and plus 2 on the other side equal to 0, and we factored it as they suggested. So since the multiplication is 0, that means either this is 0, 2 tan theta minus 1 is 0, that gives us tan theta equal to 1 over 2, right? Because 1 goes there. Okay, let me show the whole explanation of this. So 2 tan theta
equal to 1 when this 1 goes to the other side. And if I divide both sides by 2, we get tan theta equal to half. And theta will be tan inverse half. Let's go to the second one. We can write 3 cos theta plus 2 equal to 0. Cos theta, rather 3 cos theta equal to minus 2. And cos theta is negative 2/3. And now we will solve them one by one. They have already given us the domain 0 to 180, so we will think only up to 180. So tan inverse of half, half is positive, so tan is positive only here. So whatever angle we get here will be the answer after putting tan inverse half in your calculator. In this one, cos theta is negative in this quadrant and this quadrant, but more than 180 will not be accepted, so we will go with only second quadrant because 180 finishes here. And we'll put cos inverse 2/3, not minus 2/3, because minus has already given us the quadrant. So we'll put cos inverse 2/3 and we'll get this angle. Let me use my calculator to find these two angles. By the time I do this, I will again request you to subscribe to my channel and like and share this video with your friends so that we all get benefited and the knowledge is shared better way. So I got this angle as 26.56, which can be written as 26.6 degrees, 3 significant figures. And this one I got 48.18. So I'll take it as 48.2 degrees, but this is not our answer. Our answer will be always starting from 0 and reaching where this line is. So that answer will be 180 minus 48.2, which is 131.8 degrees. These two are the answers. So let's move on to the next question. Question number 4. The first term of an arithmetic progression is A. Okay, A1 is A. And the common difference D is minus 4. The first term of a geometric progression, so let me separate them, is 5A. So A1 in GP, let me write GP here and AP here, is 5A. 5 times whatever is this A. Yeah? Alright, and the common ratio is minus 1/4. Find the sum to infinity of the geometric progression is equal to the sum of first 8 terms of arithmetic progression. Find the value of A. So here we have to find S8, here we have to find S infinity. So S8 of a AP will be, the formula is in your formula sheet, so I'm straight away writing it n over 2, n is 8 here, 2 times A, the first term, plus n minus 1, which is 8 in this case, and D, which is negative 4. So let's try to simplify this. 4 times 2A plus 7. This is 7 times minus 4 minus 28. Okay. Let's say what is sum to infinity. Sum to infinity, the formula is A. A is the first term. In this case, that A is 5A over 1 minus R. 1 minus this, minus 1/4. So that is 5A over, if I add these two, because these two negatives will make it positive, so 4 times 1, 5 over 4. So I'll write just 5 here and multiply by 4 on top. The denominator of a denominator is numerator, that's what I do, and it makes it clean. So we are left with 4A. So now we have to equate the two. Here we got 8A minus 28 times 4 will be 112 equal to 4A. So let's take 4A to the other side and 112 will come to the right. 8A minus 4A equal to 112. 4A equal to 100. 12, and that makes it A equal to 112 divided by 4 back to 28. That's the value of A. Next, the kth term of arithmetic progression is 0. So find K. So they're saying kth term, which will be AK. It will be A, the first term, plus K minus 1 D. That's the formula for kth term, right? And it is 0. So 0 is equal to, now we have A, which is 28, plus K minus 1, and D was minus 4. So we can just open the brackets now. 0 equal to 28 plus, rather minus, K times minus 4 will be minus 4K. Minus 4 times minus 1 is plus 4. And 28 plus 4 will be 32 minus 4K equal to 0. Let's take 4K to the left side. 4K positive equal to 32. And that's why K is equal to 32 divided by 4, which is 8. Number 5. They have given a trigonometric graph. Most probably it is a cos graph. Yes, it is a cos graph. Okay. They're saying that it is, the equation of it is y equal to cos abx. They have written here as well as and here also. Find the value of the positive integer a, b, and c. So when we list this, we should know that in y equal to a cos bx plus c, a is the amplitude. So let's find amplitude of this. Amplitude, from the graph we can see what is amplitude, but let's make it mathematical. For amplitude, we should write maximum, whatever is the maximum, which is 8 here, minus minimum. So if we subtract the minimum from maximum, we get this distance from here to here. And if we halve this distance, that becomes amplitude. So divide by 2. And maximum is 8, minimum is minus 2, divided by 2. 8 plus 2 over 2 is 5. So the value of A is 5 because amplitude is 5. Let's move on to C, which is easier. C is the axis of the graph. That means exactly middle line of the whole graph. That means average of maximum and minimum. So axis will be maximum plus minimum divided by 2. The average of the two. Maximum is 8, minimum is minus 2, divided by 2, it comes up 6 over 2, 3. So axis is y equal to 3. The equation of axis is here. This is axis. Y equal to 3. But they're asking us the value of C. So C is just 3. Finally, they're asking what is B also. So B decides the period. The coefficient of x and period has this relationship. This is in pi, means radians. So B will be 2 pi divided by period. Okay, so period of normal cos graph is 2 pi, but this is not 2 pi. How do we find period from this graph? Just compare the two maxima or minima. Let me take two maxima. This maxima is at 8 and x value here is 0. Here this second maxima where y value is 8 but the x value is pi. And the distance between these two horizontal distance is called the period. So period of this is pi. So we will use, in place of period, we'll use pi. So 2 pi divided by pi is equal to 2 because pi and pi cancel. The value of B is 2. So we found A, B and C, all three. Moving on. This is the next part. For these values of A, B and C, use the given diagram to determine the number of solutions of the interval from 0 to 2 pi. Do we have graph up to 2 pi? Yes, we have up to 2 pi. All right. Uh, for each of the following equations, a cos bx plus c. All right. So let me substitute their values. A is 5 cos 2x plus 3 equal to 6 over pi x. So we already know the graph of this which is drawn to for us. We just have to draw the graph of this one. So this is a linear function. If I write y equal to 6 over pi x, can I write it equal to plus 0? Yeah, I can. So it comes in the format of y equal to mx plus c. So 0 is the y-intercept of the line. 6 over pi is the gradient, which is positive. That means it will be going up 6 over pi. So let's do that one. I can say that 6 is the rise and pi is the run. Yeah, that's how we find gradient. 6 over pi. So let's go back to our graph and let me draw a line which is rise is pi and run is 6. This red color graph is the one. This is the equation of y equal to 6 over pi x, right? And the question is, how many solutions do you see for this? All right. For each of the following equation, find the number of solutions. So in how many places the graph of the original one, the cosine graph, and this line intersecting, they're intersecting at 1 and 2 places. However, if we focus on this point, so it will be something like this, and the line is coming from somewhere. Let me draw a straight line coming from somewhere here like this, right? So even though it is not visible here, but the magnified version of this will be something like this. So it is actually crossing at 2 places, not 1 place here. So we will say that this is the 1 place and there are 2 places here. So total, there are 3 places where these 2 graphs are intersecting, and that's why we'll say it has 3 solutions. Okay, now let's go to the second one where they have given similar equation, exactly a cos bx plus c, same, but the right side has changed. Can you see here? It is a y, let me rewrite it in different forms. 6 over pi x I am writing first and 6 I will write later so that it becomes like mx plus c. So this 6 is the y-intercept. That means our graph should cross y-axis at 6. Then x is x, and this is the gradient but with a negative. That means this 6 is not rise anymore, it is a fall. And this pi is run, fall over run. So let me interpret this into the graph again with a blue color. That's okay. So y-intercept is 6, so I'm starting at 6. Then it will fall 6 when the run is pi. So this is the equation. Let me show you the y-intercept is 6. When it fell by 6 units, its run was pi, and that's why I took this second point. Alright, now let's count at how many places it is crossing the original graph. It is crossing here 1 and here 2, and there is no confusion like this place. In this case, there are clearly 2 intersections, and that's why we will write that it has 2 solutions. Question 6. The diagram shows a metal plate ABC in which the sides are straight line AB, okay, and the arcs AC and BC. Obviously, they look like sectors with center A and B. That's what they've written, and the radii for both is 6. Find the perimeter of the plate, giving your answer in terms of pi. So The perimeter of this plate has three parts. One is straight line 6 centimeters, so AB line segment, which is 6 centimeter. Now we have to find AC arc, which will be equal to BC arc, and which will be equal to R theta, right? So radius is known to us, it is 6. Only problem is that we don't know the angle theta. But if somehow I show you this, I join the line from C to A, will you agree that this line is also the radius 6 centimeter? Similarly, if I draw a line like this will also be 6 centimeters because this is also a radius of the arc AC. This centimeter is also a radius of BC and both are 6. That means this angle is pi over 3, 60 degrees. We know that this is an equilateral triangle. Every angle will be pi by 3 and that angle pi by 3 we will use here in this formula. So let me use it here. So our radius is 6, angle is pi by 3. So we get how much? 2 pi. 2 pi is the length of each arc. So our perimeter becomes 6 centimeter, which was already with us. Then 2 pi will be the one arc and 2 pi will be the second arc. And that answer will be 4 pi plus 6. Let's see what part B says. It says find the area of the plate giving your answer in terms of pi and square root 3. Okay, let me plan this way. If I find the area of one of the sectors, this one, I will find most of the area, only this small segment will be left. What if I find the area of this sector also? I will find the area of the segment plus the triangle extra, right? So if I find both the sectors and add them and subtract this triangle, I will get the area of the plate. So that's what I'm going to do now. So because both the sectors are exactly same, so area of a sector is half theta r square. So area of one sector will be half times theta. We just found out pi over 3. Radius is 6 and 2 times 3 is 6 and 6 will cancel with one of the 6's. So 6 pi. 6 pi is the area of one sector. But there are two sectors, right? Their area will be 2 times 6 pi, which is 12 pi. Now we have to find the area of the triangle, which we have to subtract because this triangle has been counted twice. And that will be, we can use so many ways we can do it, but the one we can use in circular measure, half AB sine C, where C is the angle between A and B. And since it's an equilateral triangle, there is no problem in counting any two sides we can write. So it will be half 6 times 6, right? Two sides are 6 and 6. The angle between them is pi by 3. So 2 can cancel with this 6, and 3. So 3 times 6 is 18 sine pi by 3. So area of the triangle is 18 sine pi by 3. Sine pi by 3 is square root 3 over 2. So 18 times square root 3 over 2, if we want exact, because they want in terms of pi and square root 3. So this is 9 and we get 9 square root 3. Area of the triangle. So now from 12 pi, which was the area of two sectors, so we'll write area of the plate, which they were asking us to find out. So total area was 12 pi of two sectors, but we have to subtract the area of the triangle. This is the exact area of the plate. All right. Let's go to the question number 7, which is a circle with center 5, 2 passes through this point. So let me draw the circle. Okay, so there is the center which is here at 5, 2, and it passes through a random point which is 7, 5. Find the equation of the circle. So best start would be that we find the radius first. Okay, and the radius will be the distance between the two points given. So radius equal to square root, by using distance formula, 7 minus 5 square plus 5 minus 2 square. So that comes out to be 7 minus 5 is 2, 2 square is 4, 5 minus 2 is 3, 3 square is 9. It is square root 13. Now, to find the equation of the circle, just take another random point, but this time the coordinates are not known. It can be anywhere on the circle, and use the distance formula again. So this time it will be r. So rather, we know the r now. Why should we use r? R is square root 13. Square root 13 equal to, okay, that random point x minus 5 is the center's x coordinate, plus y minus 2 square. Both of them are square root, so we can square both sides. So they're gone. Square roots cancelled. So 13 is equal to, let's open this, a minus b. You might be knowing this identity. A minus b square equal to a square plus b square minus 2ab. So that's what I'll use here. X square plus 25 minus 2 times x times 5 minus 10x plus y square plus 4 minus 2 4y. And just rearrange the equation by putting everything on one side. So it will be x square already there, y square minus 10x minus 4y, and then we have 4 plus 25 29 minus 13 equal to 0. So we collected everything on one side. So the final equation will be x square plus y square minus 10x minus 4y plus 16 equal to 0. Let's see what is the next part saying. The line y equal to 5x minus 10 intersects the circle at A and B. Find the exact length of the chord AB. So let me redraw a circle. Suppose this is the circle they're talking about, and this is the line they're talking about. Obviously, these two are intersecting at two places. They're asking the length of this chord. What is the length of this chord? So if somehow we find the coordinates of this point and coordinates of this point, we will find the length by using distance formula again. So to find the coordinates of these, just substitute y in the equation of the circle by its value in the line, because they're intersecting at these 2 points. X and y coordinates will be same for the circle as well as the line. So x square in the equation of circle remains x square, but y square becomes 5x minus 10 square. Again minus 10x remains it is, but 4 and y is again 5x minus 10 plus 16 equal to 0. So we are left with only one variable x here, and let's open the brackets. X square plus, again a minus b whole square, we'll open it up, so it will become 25x square plus 100 minus 2 times 5 is 10 times 10 is 100x minus 10x minus 4 times 5x will be 20x minus 4 times minus 10 will be plus 40 plus 16 equal to 0. Okay, x square plus 25x square, it will be 26x square minus 100x minus 10x minus 20x minus 130x. 100 plus 40 is 140 plus 16 156 equal to 0. And I can see that we can divide whole equation by 13, each part by 13, because they are multiples of 13, and it will make our equation easier, simpler, and easy to find its solution. So it will be 2x square minus 10x plus, oh, we have to again divide it. Okay, 12 equal to 0. All of them are even, so I can again divide by 2. So this divided by 2 is just x square minus 5x plus 6 equal to 0. And now you can find the values of x from this very simple quadratic equation. I can do it mentally. You can use your calculator. It will be x minus 2, x minus 3 equal to 0. This gives us x equal to 2. This gives us x equal to 3. That means the x coordinate of point A and B, that's saying A and B, right? So point A, the x coordinate will be 2. B, the x coordinate will be 3. And y coordinate can be found by substituting in any of the equations. Let's use this lines equation. So if I put 2 in place of x, it becomes 5 times 2, 10. 10 minus 10 is 0. So 0 is the y coordinate here. What about 3? Let's put 3. 5 times 3, 15 minus 10 is 5. So 3, 5 are the coordinates of B. And now we have to find the length of AB. Will be distance formula again. So 3 minus 2 square plus 5 minus 0 square. That is 3 minus 2 is 1, 1 square is 1, 5 square is 25. So answer is square root 26. The exact length of the chord AB is square root 26. Let's move on to question 8. Express 3x square plus 12x plus 2 in the format of this one. Okay, there are many ways we can do this, but the best one I find is that expand this one and compare it with the one you have given here. So let me again expand this. So 3 minus 3 remains 8, and again in this we will use a minus b whole square, just like we used in the previous question on circle. So x minus whole square, x minus a whole square will be x square plus a square minus 2xa, and plus b is outside, right? So if I expand the bracket now, it becomes minus 3x square minus 3a square plus minus 3 times minus 2 is plus 6 xa, rather let me write ax, and finally we have b outside. All right, so this is a constant because a and b are constants. So this is a constant, this is a constant. Let's put them together. So finally we'll write minus 3x square plus 6ax minus 3a square plus b, right? And this is what they had given. Let's write it here. Minus 3x square plus 12x plus 2. So minus 3x square is minus 3x square. Perfect, they're matching. 12x and 6ax should be equated. So 6ax is equal to 12x. Let me divide both sides by 6x. That'll make it easier, right? So 6 cancel, x cancel here as well. We're left only with a here, and 12 over 6 is 2. We got the value of a. Now we have to find b. And we can compare the constant part, which is 2 here, equal to minus 3a square plus b. And 2 equal to, now we know the a is 2, so we can put its value 2 square plus b. So 2 square is 4, 4 times 3 is minus 12. So 2 plus 12, when this minus 12 comes to the left, becomes plus 12 equal to b. So b is 14. And they wanted this format, and this format becomes minus 3 x minus a, we know a is 2 square, and b we know 14. Voila, done. This is the format they wanted. All right, let's see what are they asking in the next part. Here it is. The one-to-one function f is defined by this, same the one they asked us earlier. X is less than or equal to k. State the largest possible value of k. All right. So let's write this in the format we just found out. Okay. So this particular function can be written as minus 3x minus 2 square plus 14. This is what we got. So if I want to graph this minus 2 and 14 give us the vertex. So let me draw the vertex. Minus 2, this minus is changed to plus 2 whenever we want to get vertex straight away from this. We also call it vertex form. So this becomes plus 2 and this 14 remains plus 14 remains 14. So 214, let's say here. 214 is the vertex, and because of this negative, any quadratic function that has negative in the leading number, it opens down. So that means your graph is opening like this, right? Of this. But they're saying one-to-one function and it is less than k. So the largest possible value that will not repeat any x or y value. So let me show you what do I mean by repeating. If I draw a line like this, can you see there are two x's for same y. Y is this and y is this. For same y, we have two x's. We want one to one. That means one of this part has to go. So let me erase that part. Let me undo this one first. Gone. So I will have to erase this part so that I'm left with only this part where the horizontal line passes through only one point in the graph. So I will erase from the vertex onwards. Gone. It is one to one. So what is the largest value of x? Largest value of x is 2. After that, it is repeating. We're getting 2 x's for 1 y. And if we stop at the largest value 2, after that it will not repeat. So the value of k is 2 by this logic. It is just 1 mark question. So that's why I use the graphical method to answer this. It is now given that k is minus 1. So what have they're given that the largest, they're not dealing with largest one now. They're saying minus 1. Let's say minus 1 is here. So I will erase the function after this. So let me erase it. So they stopped at minus 1. They didn't go to plus 2. Suppose this is the graph. Very small graph starting from minus 1 and coming down somewhere here. Okay. It is now given that k is minus 1. State the range of f. Range is the y values. If this is minus 1, what is the y value? So let's substitute in the equation we have here. So minus 3 and x is minus 1 they're saying. So minus 2 square plus 14. So it will be minus 3 and minus 3 square will be 9. This minus 1 minus 3 square 9 plus 14. So it becomes minus 27 plus 14 is minus 13. That means the y coordinate here, this point is minus 1 minus 13. So the maximum value y can have is minus 13. All values of this are under minus 13. So the range will be y, or you can write f, right? Or fx is less than or equal to minus 13. Are they saying minus 1? Yeah, minus 1 is there. That's the answer. Some of you may comment that, oh, your y value doesn't look like minus 13. It is above x-axis. It is just a representative drawing. I have not drawn it to the scale. So the point is somewhere down there, but I have drawn it for the simplicity's sake. So don't complain that it doesn't look like minus 1, minus 13 here. All right. Let's move on to another part it has, which will be, okay, let me do it here. Paste. Find the expression for inverse of x. Okay, whenever we have this vertex form where we have a minus this format I'm talking about, whenever this is the format, it is very easy to find inverse. Always, whenever they ask you to find the inverse of an quadratic function, always convert it to vertex form. So let me write the vertex form first. It was fx equal to minus 3x minus 2 square plus 14. This was the one. So in place of fx, we can write y. To find the inverse of this, we will exchange the places of x and y. So it becomes x equal to minus 3 y minus 2 square plus 14. Now we have to isolate this y to get inverse function. So x minus 14, yeah, this 14 goes to the left, becomes minus 3 y minus 2 square. Now we'll have to get rid of this minus 3 by dividing both sides by minus 3. They cancel out. Our denominator negative is not good looking. So what can I do? I can multiply this by minus 1 and this by minus 1 up and down so that things become positive. So let me continue it here. When minus 1 multiplies with x minus 14, they will change their places. So it will become 14 minus x, and obviously minus 1 times minus 3 will be positive 3. And here we'll have y minus 2 square. So next thing is to get rid of this square. So we'll square root this, we will square root this also. So this square and square root get cancelled out, and here we'll write plus and minus both because we can have both of them, right? So now we are left only y minus 2 here, so 2 will come to the left side. We'll write 2 plus minus square root 14 minus x over 3 equal to y, and that is f inverse x. However, this plus and minus, because they have clearly said in previous parts that it is less than k in definition of the function. They said it is less than k, that means it is one-to-one function. That means we have to ignore one of them, either positive or negative. Since it is less than k, that means we are keeping the lower side, lower value of y, and that's why this plus must go. Only minus will be left here. So I'll erase this plus and minus, and I'll keep only minus here. So write minus 2 minus square root 14 minus x, and that is f inverse x. Question 9. A curve has an equation y equal to fx. Question 9. A curve has an equation y equal to fx, and it is given that the differentiation of fx is this. Given that when x is 1, that's what it means. F1 means when x is 1, y is minus 1, 3. 1 over 3 rather. Okay, find fx. That's what they're saying. So, to find fx from f prime x, the differentiated one, we have to integrate this. So, we will integrate f prime x to get fx. And that's why we will integrate 2x squared minus 7 minus 4 over, let me write 4x to the power minus 2. Change it to this format, that will help. And integrate with respect to x. So the integration of 2x squared will be 2x cubed over 3, minus 7 will be minus 7x, and minus 4x cubed will be minus 4x to the power minus 2 plus 1, which is minus 1, divided by minus 1. So we can cancel these negatives, and then there will be c, and that is fx. Now, since they have given this fact, f1 is minus 1/3, so we can write f1 here, which is minus 1/3. And now substitute each x by 1 because x is 1. So 2 1 cube over 3 minus 7 times 1 plus 4 1 to the power minus 1. Let me write this way. C. Right. So minus 1/3 is here. So leave it here.
and this becomes 2/3. This will also go to the left side and become minus 2/3. This minus 7 goes to the left, becomes plus 7. And 1 to the power anything is 1, so 4 times 1 is 4, and when it goes to left becomes plus negative 4, and that is C. And the purpose was to find C. Minus 1/3 and 2/3 together they will be minus 1. So minus 1 plus 7, 6. 6 minus 4 is 2. C is 2. So the final equation, let me write here, is fx equal to, which was here, 2 over 3x cubed minus 7x plus 4 over x, because x power minus 1, when it goes and becomes denominator, it becomes positive, so it can be written as 4 over x. And c now we got as 2. This is fx. Part B. Find the coordinates of the stationary points on the curve. So to find the stationary point on the curve, we equate the differentiated part equal to 0, because differentiated part is nothing but gradient of tangent, right, at a specific point. And at stationary point, when they turn back, the tangent of those points is horizontal line, the gradient of tangent on those points is 0, and that's why we make the first derivative equal to 0. So let me do that here. F prime x equal to 2x squared minus 7 minus 4 over x squared, and that has to be equal to 0. Now in this equation we can see that we have a denominator x squared with one of the terms, so let's multiply whole of the equation with x squared so that this x squared is taken care of. So x squared multiplied by 2x to the power 2 will be 2x to the power 4. Minus 7 multiplied by x squared is minus 7x squared, and minus 4 over x squared cancel. We are left with just minus 4, and this becomes our equation, which is like a quadratic equation. So let's assume x squared is equal to t. So this becomes a perfect quadratic equation. So 2t squared minus 7t minus 4 equal to 0, and let me solve it as usual by factoring. So 2t squared minus 8t plus t minus 4 equal to 0, 2t minus 4 plus t minus 4 equal to 0. If you want, you can use a calculator. The calculator gives you the solution straight away. You don't have to do all this, but I ensure that you know the reason behind the solutions. So 2t plus 1 is equal to 0. That gives us t equal to minus half. This gives us t minus 4 equal to 0, which is t equal to 4. So our assumption was x squared is t. So when we write these two solutions, it will be x squared equal to minus half and x squared equal to 4. Square root both sides to get x. So x and square root of a negative is not possible. So this one is undefined. So we will not accept this answer. However, this one, we square root x will be plus and minus 2. So they say coordinates of the stationary points. We got the x coordinates plus and minus 2. Let's find y coordinate. And for y coordinate, which is equal to fx, let's put these into the given equation of the curve that we found out in part 1. Let me go to that one again. So that was 2x cubed. Let me go again. 2 over 3x cubed minus 7x plus 4 over x plus 2. 2x cubed over 3 minus 7x plus 4 over x plus 2. So first we have to find the y coordinate for plus 2. So we'll write f2 will be 2 times 2 cubed over 3 minus 7 times 2 plus 4 over 2 plus 2.
So 8 times 2 is 16 over 3 minus 14, 4 over 2 is 2 and 2 again. Minus 14 plus 4 is minus 10. So 16 over 3 minus 10 will be minus 14 over 3. Similarly, f minus 2 equal to 2 minus 2 cube over 3 minus 7 times minus 2 plus 4 over minus 2 and then plus 2. So it becomes minus 16 over 3 this time plus 14 minus 2 plus 2. They cancel out and this comes out to be 26 over 3. So coordinates of stationary points are 2 negative 14 over 3 and 2 26 over 3. Move on to part C. Okay, it says find the second derivative. So let's have the first derivative with it and we can get a second derivative from it. So second derivative will be the derivative of this particular function. So second derivative will be the derivative of 2x squared is 4x. Derivative of minus 7 is 0. And derivative of, let me do it somewhere here, minus 4x to the power minus 2. That's what I can write this 4 over x squared as. And so minus 2 comes and multiplies with minus 4 becomes positive 8 and goes down by 1, which is minus 3. So it will be minus plus rather plus now 8x to the power minus 3. If you want to make it positive, 4x plus 8 over x cube. This is second derivative. Next, hence or otherwise determine the nature of each stationary point. So nature of each stationary point can be found by second derivative itself. So nature of stationary points. So the first one was 2 minus 14 over 3, right? This was the stationary point. And substitute the x value in the second derivative. So f double prime 2 will be 4 times 2 plus 8 over 2 cube, which is 8 and 8 cancel out, and 8 plus 1, 9. We are not interested in the value, we are interested in the sign of this, which is positive. Positive means 2 minus 14 over 3 is a minimum. Whenever the second derivative gives you a positive number, it means that the curve at that particular area is opening up. That's why we get a minimum number out of it. Similarly, let's put f second derivative of minus 2, and that will be 4 times minus 2 plus 8 divided by minus 2 cube, which will be minus 8, and 8 divided by minus 8 will be minus 1, which is minus 9. So it's negative. So minus 2, 26 over 3 is a maximum point. Obviously, if the second derivative is negative for that particular x value, it shows that it is moving, it is opening down at that particular instance, and the turning point or stationary point is a maximum. Let's see what next question number 10 has for us. They're asking us to integrate, find the definite integral of this, and it is very uncommon that they have given an infinity as one of the limits. So let's try to integrate first and then we will put these limits into it. So can I convert this in a different look like this? 3x minus 2 to the power minus 3 over 2 dx. Okay, I'm not writing limits as of now. First, my focus is on to integrate this. We can. And since it's a linear, just treat it as a power of a function. So whenever we integrate power of a function, we write the function itself
and add 1 to its power and divide it by the same power. But unlike normal functions, we further divide it by the differentiation of what is the content of the bracket. So the differentiation of 3x minus 2 is just 3. So we divide the whole thing by this, and this becomes the integration. And now I can write the limit here. It was 1 to infinity, right? Let me simplify this first and then we'll proceed. Okay, the bracket starts again. 3x minus 2 to the power 2 minus half minus 1 over 2 over minus 3. Yeah, minus 1. In place of minus 1, I'm writing minus 3 because it will multiply with this 3 over 2. So I'm writing 2. Denominator of a denominator becomes numerator plus c. 1 to infinity. And let's substitute the two limits now. So let's take this minus as the common one. Minus 2 over 3. 3 times infinity minus 2 to the power minus half plus c. Okay, that's the first part. Minus 2 times 3 times 1 minus 2 to the power minus 2 or 3, that will be right. Okay, to the power minus half plus c. So let's 3 times infinity will be infinity. Infinity minus 2 will be infinity. So the big number, you subtract 2 from it, what difference it makes? Nothing. So we'll be left with, let me write the first bracket here, minus 2 over 3 infinity to the power minus half plus c minus, here there will be something, 3 times 1 is 3, 3 minus 2 is 1, 1 to the power anything is 1, so just minus 2 over 3, nothing else, plus c. Let's open the brackets and make this positive. So minus 2 over 3 infinity to the power half plus c minus 2/3 minus c. This plus and this minus c will cancel out. Infinity to the power anything will be infinity, and 3 times infinity is again infinity because it's a big number. So you multiply it by 3, it remains a big number. So 2 over infinity minus 2, rather this will be positive, right? This was minus, so it will be positive. Positive 2/3. Okay, so infinity means a very big number, billions and trillions of numbers. 2 divided by those numbers will be almost 0. So this becomes 0 and we are left with 2/3. And finally 2/3 is our answer. Let's see what is there in part B. Okay, they have given a diagram which shows the curve with equation y equal to 3x minus 2. Okay, the same one. The shaded region is bound by the curve. Okay, and 1 and 2, x equal to and 1 and 2. The shaded region is rotated 360 degrees. All right, if you rotate this, it will become something like this, and like old style loudspeaker we used to see earlier. All right. The shade region is rotated, and find the volume of the revolution. All right. So to find the volume, we should first see this is the formula for the volume of a shape rotated by 360 degrees. So y square first. So we have to square this one, this particular given expression. So let's do it. Let's write it here only. Pi 1 over 3x minus 2 to the power 3 over 2 square dx. So pi remains pi, integration sign remains integration sign, and 1 square is 1, but 3 over 2 multiplied by 2 will be 3, so it will be 3x minus 2 cube dx. And now we will integrate this and give limits from 1, 2, 2. Alright. So integration of this will again rearrange the look of this, and it will become 3x minus 2 to the power minus 3 dx 1, 2, 2. There's a pi in front. So now we will integrate this one, because again it is a power of function, so it will be integrated like this. The power 3x minus 2 minus 3, and 1 will be added to it and will be divided by the same, and uh, further divided by the differentiation of 3x minus 2, which is the content of the function, which is differentiation is 3, and pi in front again, plus c, and our limits are 1 to 2. So let's plug in the values here. So pi 3 times 2 minus 2 over, okay, minus 3 plus 1 is minus 2 times 3 is minus 6, and minus 2 is the exponent of only the numerator, okay, plus c minus 3 times 1 minus 2 to the power minus 2 over minus 6 plus c. Okay, let's open the bracket again. 3 times 2 is 6, 6 minus 2 is 4 to the power minus 2 over minus 6. Let's put minus here. Now it's safe to do that. C minus, and when we open this bracket, this minus 6 with this minus will become positive. 3 minus 2 is 1, 1 minus 2, power minus 1, anything is 1, so 1 over 6 minus c. Plus c and minus c cancel out, and we're left with, okay, first we have to make this positive, so minus 1 over 6 times 4 square, it becomes a denominator itself to become positive exponent, and 1 over 6, alright, pi minus 1 over 96, yeah, 16 times 6, 96, plus 1 over 6, and if we solve this, it becomes pi and 15 over 96. We can divide by 3, 5 and 32. Finally, the volume is 5 pi over 32 units cube. The normal of the curve at 1, 1 crosses the y-axis at A. Find the y-coordinate of A, y-coordinate, okay? So this was the curve, something like this. 1, 1 was somewhere here. This is the normal, so it crosses y-axis, yeah, at A. Now we know that at y-axis x is 0, so they are not asking you the x-coordinate, they're asking just the y-coordinate of this. So to find, because normal is the one that is crossing y-axis, so we should write the equation of a normal first. Y minus y1 equal to minus 1 over mx minus x1, where we have been given x1 is 1, y1 is 1, y we have to find out equal to x is 0, and m is the gradient of tangent at 1, x equal to 1. So this is what we have to find out somewhere. So let me try to find here. For that, we'll have to differentiate the equation of the curve first. So let's see what was the equation of the curve. This was the equation of the curve. So let's change this, the look of this question first. 3x minus 2 to the power minus 3 over 2, it is power of function again. So dy over dx will be minus 3 over 2 comes in front, 3x minus 2 to the power minus 3 over 2 minus 1, and further we multiply by the differentiation of the content of the bracket, which is 3. So it becomes minus 9 over 2, 3x minus 2 to the power minus 3 over 2. We could have simplified this or written in some other form, but we are interested in m, the gradient of tangent, which will be used in equation of the normal here.
So just substitute 1 to get dy dx. So let's substitute x equal to 1 in this. So it becomes gradient of tangent becomes m. 9 over 2, 3 times 1 minus 2 to the power minus 3 over 2. 3 times 1 is 3, minus 2 is 1. 1 to the power anything is 1. So minus 9 over 2 becomes our m. M is minus 9 over 2. So we'll use the reciprocal for normal in our equation, which will be 2 over 9. Minus 9 over 2, the negative reciprocal is 2 over 9, and now everything is right, we'll get the y value. So y minus 1 equal to minus 1 multiplied by this will be minus 2 over 9. And now let's move this 1 to the other side. It will be y equal to minus 2 over 9 plus 1, that is 7 over 9. This is the y coordinate of the normal that is crossing y-axis at A.